Good morning, students. This is a electric classroom activity. It is a one type of innovative and collaborative learning method so that students can easily understand the different concepts involved in their course. So, my name is Mallikarjun Bidri, Assistant Professor, Department of Mechanical Engineering, GM Institute of Technology, Downway. I will consider my course Turbomachines. In this course, I am going to learn different objectives. The course aims at giving an overview of different types of turbomachinery used for energy transformation, such as fans, pumps, compressors, as well as hydraulic and steam turbines. Explain the working principles of turbomachines and apply it to various types of machines. It will focus on application of turbomachinery in power generation, power absorption, and transportation sectors. Coming to an introduction of turbomachines, the basic definition involved in the turbomachine is a device in which energy transfer takes place between the flowing fluid and a rotating element due to a dynamic action and results in change of pressure and momentum of the fluid. Classification of turbomachines are power generating turbomachines, power absorbing turbomachines, power transmitting turbomachines. Power generating turbomachine is one which converts fluid energy in the form of kinetic energy or pressure energy into mechanical energy in terms of rotating shaft. Turbines are the best examples for this type of machine. Power absorbing turbomachines is one which converts mechanical energy into fluid energy. Compressors, fans, pumps, and blowers are the best example of this type. Power transmitting is one which is used to transmit power from the driving shaft to driven shaft with the help of fluid. Comparison between positive displacement devices and turbomachines. In that positive displacement, it involves changes in volume or a displacement of the fluid, whereas in turbomachine, change in pressure and momentum of the fluid. Here, unsteady flow of fluid. In positive displacement machine, turbomachine, steady flow of fluid. Whereas in positive displacement machine, the mechanical feature involves reciprocating forces, vibrations, which involve more. Whereas rotating forces can be completely balanced and vibrations are eliminated. And efficiency of conversion process involves higher efficiency, whereas in turbomachines, efficiency is low. Consider volumetric efficiency much below than of turbomachines. In case of positive displacement, it is almost 100% in turbomachines. Fluid phase change and surging will involve no serious problems in case of positive displacement, whereas in turbomachines, it involves cavitation in pumps and turbines, therefore leads to erosion of blades. So, power generating machine, we have a different way of doing efficiencies, like power generating efficiencies, actual shaft work output to be hydrodynamic energy available from the fluid, whereas power absorbing machine involves the efficiency ideal work input to the actual shaft work input. Mechanical efficiency is the ratio of mechanical energy supplied to the rotor to the actual shaft working. Coming to a dimensional analysis. So the dimensional analysis is a mathematical technique deals with the dimensions of the quantities involved in the process. Basically, dimensional analysis is a method of reducing the number and complexity of experimental variables that affect a physical phenomenon by using sort of compacting technique. There are three repeating variables create pi terms in the Buckingham pi theorem. These variables are geometric variables, kinetic variables, and dynamic variables. The pi term involves flow coefficient, or it is also called capacity coefficient, specific capacity. The term Q divided by MV cube is called flow coefficient. It signifies the volume flow rate of the fluid through a turbo machines of unit diameter of runner operating at unit speed. Speed ratio is defined as the ratio of tangential velocity of the runner to the theoretical jet velocity of the fluid. So coming to head coefficient, the term GH divided by n square d square is called the head coefficient or specific head. It is a measure of ratio of fluid potential energy and the fluid kinetic energy while moving at the rotational speed of the wheel U. Coming to power coefficient, the term P divided by rho n cube d to the power 5 is called power coefficient or specific power. It represents the relation between the power, fluid density, speed, and wheel diameter. For a given machine, the power is directly proportional to the cube of the tangential speed of the wheel. Specific speed is the dimensionless term, is the parameter of greatest importance in incompressible flow of machines. Specific speed is only the parameter that doesn't contain linear dimensions of the runner. The specific speed can be expressed in terms of discharge Q for a power absorbing machine or power P for power generating machines. The specific power is referred as the ratio of power in or out of the turbo machine to its weight or unit mass into volume. The specific speed of a pump is defined as the speed of a geometrically similar machine discharging 1 cubic meter per second of water under a head of unit meter. So normally the derivation will ask based on the concept of alternative method. It is we have to solve how to arrive this equation. Ns is equal to n square root of q divided by h to the power of 3 by 4. Coming to a specific speed of turbine, Ns is equal to square root of p into n divided by h to the power 5 by 4, where Ns is specific speed of a pump in case of power absorbing machine and specific speed of turbine in case of power generating machine. Specific speed of a turbine is defined as the geometrically similar machine which produces 1 kilowatt power under a head of 1 meter. What do you mean by unit quantities? It is the quantities as unit flow, unit speed, and unit power, which are the values of the quantities under the consideration per unit head. So this is a basic definition of unit quantity. So correspondingly, we are going to know what do you mean by unit flow. Unit flow is the flow that occurs through a turbine while working under a head unit meter. Next comes unit speed. Unit speed is the speed at which machine runs under unit head. U is equal to m divided by square root of h. Whereas unit flow, which is q divided by square root of h. Unit power is the power developed by the hydraulic machine by working under unit head. P is equal to p divided by h to the power 3 by 4. Model studies. For this, prediction of model and prototype should be geometrically, kinematically, and dynamically similar. Model is a small scale replica of the actual machine, and the actual machine is called prototype. So I referred many previous year question papers. So normally they will ask common questions, that is difference between positive displacement machine Turbomachines. It is always common question in any question paper. But if you consider small derivations like what do you mean by specific speed, how we are going to derive the equation ns is equal to L over the square root of P divided by square root of 5 in case of turbines is equal to L divided by L square root of Q divided by square root of P divided by in case of pumps. So that derivation normally they will ask. So I referred this question paper in December 2015, January 2016, and in June, July 2016. So here many questions are repeated. So as these problems you have to solve. These are the assignment problems. So next comes if you consider these the difference and the significance of low coefficient, fault coefficient, head coefficient. And next comes the series scheme involves the significance of physics, leading questions, and what is the effect of Reynolds number on of turbomachines. And the next question paper is recent VTU, June 2018. So they use pump problem. So here in this problem we are going to consider flow coefficient, head coefficient as well as power coefficient. So based on that concept, model and prototype we have to make. Then we have to calculate the power as well as ratio of discharge, QP divided by Q, and speed for the prototype. Okay, so these are the repeated questions. So this is a hint for the problem which are asked in December 2017 and 18. So some typical problem where I am giving hints, so you refer it and solve your own. So I refer these are the textbooks, Principles of Formation by D.G. Shafran. Fluid mechanics and thermodynamics, Sir Dixon, introduction to energy conversion, and 3 Turbomachinery, B. Patanjali and Prasad, UH International Publishers, and turbines, compressors, fans, semi-hair, Tata Motors, Turbomachinery by B. Pi, United Publishers. So these are the references I refer. So kindly go through this video, so it will be helpful for your course, and give the feedback on this course. Make 3 batches based on your class strength and discuss yourself and solve these assignment problems and discuss with yourself so that it will be more useful. Thank you.